So we meet again, 6.2, multiplying and dividing radical expressions. Now one thing that is very important about this is we can multiply and divide radical expressions, but only if this right here, this index is the same. So this index, both have ends. So if the index is the same, just like so, then you can multiply the numbers underneath and rewrite it, and then simplify it if you can. So this very first one, when I'm looking at this, I cannot simplify it. Why? Because we have a 3 here, and we have, if nothing's there, that would be a 2. You cannot combine these two. You cannot combine these two, so no, you cannot simplify that. Or else you can just rewrite the same thing. Second one, they have the same index, 3 and 3. So now I can multiply those two together. And when I multiply those two together, I would get the cubic root of -8. And 8 should be one of those cubic roots that you just know. Now, because it's a cubic root of a negative, your answer will be negative. And the cubic root of 8 is 2. So my answer here would be -2. C and D, I want you to try to do yourself. We'll go over those tomorrow in class. Next two questions. Just like the cubic root of 8 was a perfect number, so we got 2. Or if it's not, square root of 24, the cubic root of 24, then you have to simplify it. There's actually two different ways that you can simplify roots. You can use your factor tree, prime factorization, or else you can use perfect roots. Now I'm going to be going over perfect roots in class, so I'm going to be showing you the factor tree method here. So my factor tree for both of these for 24, you want to figure out the prime factorization. So 24 could be, you could start off with 6 and 4, that multiplies to get 24, and then keep on breaking it down until you only have prime numbers left. So in this case, that's a 2. I don't know why it's not writing 2. I'm looking for square roots, so I'm looking for pairs here. So I have a pair of 2's right here. And now if you circle something, like in this case, I have a pair of 2's, I can take out a 2, leaving me with a 2 on the outside. Anything that's not circled has to stay within the root. So I have to multiply those two numbers together, and this becomes 2 square root 6. Now the same type of thing for 24 over here. So my prime factorization, I could have started with 12 and 2, just to let you know. It doesn't matter which two numbers you start with, because I can still break this down. I'm still going to get 3 times 2 times 2 times 2. Cubic root, I'm looking for groups of 3. So here's a group of 3. So that still means I can take out 1, 2, and the only thing that's left inside is that 3, so this would be the cubic root of 3. 2 cubic root of 3. So simplifying this, I'm going to do B, and then I'm going to have you do A by yourself, and we're going to be going over A in class. So I'm looking at B. Again, I'm going to do my prime factorization. Now it's even, so I'm going to do 2 and 64 because that's easier. Now one thing that you can do is 12 divided by 2 is 6 and 8 divided by 2 is 4, so that's why it was pretty easy to do in my head. I have 8 times 8 is 64, 4 times 2. Now when you are doing this, you only are looking at the numbers that do not have branches. So in this case, I mean the 2, this 2, this 2. I don't do anything with this 4 because it has branches. This 2, this 2, this 2, this 2. I'm looking for groups of 3 because it's a cubic root. So here's a group of 3. Here's a group of 3. And then I look, this 2 is left over. So what I have now, I have 2 groups of 3. So 2 times 2, and then there was a 3 left over, just like that. Now, again, I'm looking at my x also. If you look, I have an x here. So one thing that you could do, I'm going to rewrite it over here, is I'm going to rewrite this as cubic root of x to the 6 and the cubic root of x. Now, when I do that, you should notice that 6 plus 1 is 7, so that's why I broke it up. The reason I did this is because now I see that when I break this up, this would give me x squared, because there's 2 groups of 3 in there, and the cubic root of x. So if I write my whole answer all together, 2 times 2 is 4, and then I have x squared, and then I still have a cubic root of 2 and x. That right there would be my final answer. Now again, I'm showing you a lot of work, but some people can do a lot of this in their head, especially when we do perfect cubes. So I want you to try to do A by yourself. So push pause, do A. So now we're going to be doing the same thing, but we're actually multiplying first. There's, again, two ways that you can do this. You could simplify both radical first and then multiply the two together. I personally like to multiply together first. I'm going to do B, and then you're going to try to do A. So I'm going to multiply these two together first. So I'm going to have square root, so 2, of 1,575, 45 times 35, x to the 6, because I'm adding x to the 5th times x would be x to the 6th, and y to the 7th. Now I'm going to do my factor tree here. And when I'm doing my factor tree, it's actually pretty easy if I start off with the two numbers that multiplied to get that number. So I have 45, I have 9 and 5, 3 and 3, here I have 5 and 7. All those numbers are prime. So now I'm looking for groups of 2 because this is a square root. There's no number there. We're looking for groups of 2. Here's a group of 2. Here's a group of 2. Now one thing I can do, there will be 3 groups of 2 in x to the 6th. So I would have a 3 out front because there's a group of 2. This 5 out front because there's a group of 2. I would have x cubed out front because this right here, the square root of that would give me x cubed. I could rewrite y to the 7th as y to the 6th times y. Now this is stuff that you could be doing in your head. You don't always have to write out your work. But I'm going to show you where I'm getting this from. So y to the 6th, if I take the square root of that, that would give me y cubed. So what I have left over then in this square root is I have this 7 here because we didn't do anything with that. And I also have this y right here because we couldn't do anything with that. So now you shouldn't leave your answer like this because of the 3 times 5. So my final answer would be 15 x cubed y cubed with a square root of 7y. One thing here though, you have to be careful about this now, is that I have to make sure to have my absolute value right here so that I know that those will be positive numbers because we started with an even root and we got odd exponent. So we need the absolute value right there. Now when I'm dividing, there's 2 things that when you're dividing what you should look for. First, if you're dividing with the same index, just like here, you can rewrite that if it's a root over the root, the same index, as 1 simplify, and then you can simplify that fraction. This is the easiest way, and then we'll actually get into rationalizing our denominators in a little bit. So I could rewrite this as the square root of 18x to the 5th over 2x cubed, which is the same thing as the square root. So I do 18 divided by 2 would give me 9. X to the 5th divided by x cubed, there's more x's on top, would be x squared. So now my final answer, I can take the square root of 9, and that's 3, and the square root of x squared is x, but remember I need to have my absolute value right there to make sure that it's a positive number. So that's all I have to do when I have that. And I'm going to go through B also, and then you get to go through C by yourself. So again, my roots are the same. They're both cubic roots. So I'm going to rewrite this as the cubic root of 162y to the 5th over 3y squared. So that's your cubic root of 54. 162 divided by 3 is 54. And x to the 5th divided by x squared would be y to the 3rd. Now I have to see if I can simplify that. Now if you want, you can do cubic root in your calculator, but that's not a perfect cubic root. So one thing I'm going to do is my prime factorization, my factor tree. So I'd say 9 and 6, 3 and 3, 3 and 2. So I'm simplifying this. Here's my group of 3. I need a group of 3 because my index here is 3. So I have 3. There's one group of y here. It's odd, so I don't need an absolute value. You can take out one full y, and then I would still have the cubic root of 2. So you should pause and try to do C by yourself. Now let's say we have a root and it's not so nice. It's not such a nice guy. We have to rationalize the denominator. Rationalize the denominator means we do not have any radicals on the bottom of a fraction. The reason why we do this is because it's easier than to combine like terms. It's easier to see if we can combine any radicals together. That's why we rationalize the denominator. Now, The first one, if I have just a root on the bottom, just like this, in order to get rid of that, I want to make sure that that could become a perfect square. So I'm going to zoom in here just on this one. So I can multiply by this, by the square root 3 over square root 3. Now, one thing that this number that you multiply by, it has to be 1. So something over itself, this number has to be 1, because then I'm not actually changing the product. So then I'm going to multiply those together. Again, this is me showing more work than need be, but it would be 2 square root 3, because you're multiplying, over square root 3 times square root 3 is the square root of 9. And then I can simplify that as 2 square root 3 over 3, because the square root of 9 is 3. So something you notice is that when you multiply it, it should, on the bottom of your fraction, once you're all done, should be what originally was in the root, unless if you could simplify more. Also, you don't have to write this. I know that some people can do this step in their head and then take the square root and go from here to here. So the second one. Now I have two things underneath my root and I have a root on top. I really only care about the bottom. We really only care about the bottom of the root, so I'm going to multiply by the square root of 6x over the square root of 6x. So when I multiply this together, now since they have the same index, I can multiply my roots. So 6 times 3 would give me 18, and I still have 1x. And then 6 times 6 would be the square root of 36, and x times x is x squared. There's two things about this one, is I can simplify the top, because there's a square root of 9 in there, because if I do my factor tree over here, this would be like 9 times 2, 3 times 3. Here's my groups of 3. So I can take out a 3, and then I'd be left with this 2 on the inside, and I can't do anything with the square root x. And on bottom, square root of 36 is 6, and the square root of x squared is x. This is where you have to have the absolute value. But now, I notice once I simplify that, I can simplify this right here. So what I actually have as my final answer is the square root of 2x on top over 2 absolute value of x. So I want you to try the next one by yourself. So push pause, please, and try the next one by yourself. So now this is where it gets a little bit more tricky. So this is a cubic root. So in order to have to get rid of the cubic root, you have to figure out what you need in order to simplify that. So right now I have 1, 2, but remember, to simplify in a cubic root, you need groups of 3. So what I'm going to multiply by this is the cubic root of 2 squared. When it's ever on the bottom, it also has to be on top. Why am I picking 2 squared? So when I multiply this together, I'm going to have it written as x on top, my cubic root of 2 squared, over my cubic root of, here I have 2, here I have 1, so the cubic root of 2 cubed. So the reason why I picked 2 squared is because once I added these two together, it gave me a factor of 3. So now I can easily simplify this. So my final answer would be x, and then the cubic root, I don't care if you leave this as 2 squared or if you write 4, over this simplified is just going to give me 2. And that right there is my answer. So we are going to work on A. However, I'm not going to be doing B, C, or D. If you want to attempt then, go ahead to see if you understand the material. Otherwise, we will be going over that in class, because I do realize that this can be a very difficult concept. Now, before I actually start trying to rationalize this root, because there's the root on the bottom, I'm going to write my 12 in prime factorization. What does that mean? Again, I'm going to do my factor tree here. So I'm going to do 4 and 3, 2 and 2. So all I'm going to do is rewrite this so I have my cubic root on top. I didn't really need to write it that long. That's a squared. Over my cubic root on bottom. When I write the 12, I'm going to rewrite it as 2 squared times 3 y squared z. I can't simplify anything in there right now, so I'm not going to try to simplify. But now I have to rationalize my root. So I have to figure out what should I multiply this by. So it's always the bottom. That's where you're focusing. You're looking at the bottom of the fraction first, and once you figure out what the bottom should be, it's the exact same thing on top. So I'm looking at this. I already have 2 2's. It's a cubic root. I need one more, so I'm going to add 1 2 here. When I look at my 3, I have 1 3. In order to make a group of 3, I need 2 more. So I'm going to do 3 squared. Look at my y's. I have 2 y's. I need 1 more y, so I'm going to multiply by y. And I have 1 z. I need 2 more z's. So once I have that on bottom, it's the exact same thing for on top. 2 to the first times 3 squared y z squared. And now I actually multiply it together. So my cubic root on top would be 5 times 2 times 3 squared x squared y times z squared. Now we will be simplifying that, just to let you know. And then on bottom, if you did it correct, you technically do not have to write this step, but I'm going to rewrite it. So I have 2 squared times 2 to the first would give me 2 cubed. 3 to the first times 3 squared would give me 3 cubed. Y squared times y to the first would give me y cubed. And z times z squared would give me z cubed. So, simplifying this then, I can multiply these all together right there. So this would be 10 times 9. So this would be the cubic root of 90. And then I have my x squared, y, z squared. And then bottom, because all of these are a factor of 3, these all would simplify just to be 1. So I would have the 2 times 3, which would give me 6. And then I just have my y and z. Y and z. And I can't simplify that any further. So this right here is my final answer. Again, if you feel up to it, I want you to do B, C, and D. If not, just wait and we're going to do this in class. Thanks for spending this time with me. I appreciate it. And I do realize that this was quite a long one. You have a wonderful day. Or night. Or morning. Or super midnight, like late night, because you were just, procrastinating.